In this video, we will analyze in detail what happens in a refrigeration or air conditioning system when the dimensions of the capillary tube are not correct. This issue can arise especially when replacing the compressor and focusing only on the electrical power of the compressor motor without verifying the cooling capacity. This can lead to performance issues in the system and significantly affect its operation. There are four main scenarios we must consider. A capillary tube longer than required. A capillary tube shorter than required. A capillary tube with a larger diameter than necessary. A capillary tube with a smaller diameter than necessary. We will analyze each case separately to understand the consequences that may arise in each situation. Case 1. Capillary tube longer than required. If we install a capillary tube that is longer than necessary, it creates a greater restriction to the mass flow of refrigerant. The longer the capillary tube, the greater the control over the refrigerant flow. This higher restriction causes more refrigerant to remain on the condenser side, primarily affecting high pressure in the system. Although low pressure may also be influenced due to the interconnected nature of the system, the most significant impact is observed on high pressure. An increase in high pressure also affects the compressor's electrical consumption, increasing its energy demand. Case 2. Capillary tube shorter than required. When the capillary tube is shorter than recommended, the opposite occurs. Less flow restriction, allowing refrigerant to move more easily from the condenser to the evaporator. This significantly reduces high pressure, which can compromise the condensation process. For condensation to occur efficiently, a sufficient pressure level is required. Low pressure may also be affected, as more refrigerant reaches the evaporator, which could slightly increase low pressure. However, the most critical effect is on high pressure, which may drop to critical levels, preventing proper condensation and disrupting the refrigeration cycle. Case 3. Capillary tube with a larger diameter than required. Now, keeping the capillary tube length fixed but increasing its diameter, we observe that the low pressure side is most affected. Although high pressure may also experience some variation, the most significant change occurs in low pressure, which can drop to critical levels. In extreme cases, high pressure may not form properly due to the lack of restriction, preventing the necessary pressure differential from developing in the system. Case 4. Capillary tube with a smaller diameter than required. If the capillary tube has a smaller diameter than needed, the main effect will also be observed in low pressure. In this case, low pressure will drop significantly due to the higher restriction imposed by the narrower tube. As a side effect, high pressure will increase, leading to higher electrical consumption by the compressor. This increased energy consumption could reduce system efficiency and cause overloading of the compressor motor. Conclusion and recommendations. When replacing a compressor in a refrigeration or air conditioning system, we must not only focus on the motor's power, but also on its cooling capacity, expressed in BTU per hour, kilocalories per hour, watts. The capillary tube must be correctly sized based on cooling capacity, system operating temperature,